RAC's purpose to go to the moon is to understand the environment better. Artemis astronauts are going to be living there long-term, and so will other humans. And it's important to get the right materials that last and are safe in the long run. Hi, I'm Dennis Harris, the Lunar Payload Manager for the Regolith Adherence Characterization project. I'm based here in Huntsville at Marshall Space Flight Center. RAC is an instrument designed to see how different materials react to dust on the surface of the moon. It's got 2 wheels, 15 samples in each wheel. The samples are made up of various materials. Some are spacecraft material, some are aluminum, some may be glass, some may be spacesuit material. And what they're going to try to determine is how dust sticks to it. The science out of RAC is to get a long-term view of what dust really does and what materials are best for surface operations, both for the Artemis astronauts and for any spacecraft that might want to land there in the future, because dust can be an issue. I think the purpose of RAC is to look at the long-term effects of dust on different materials, which will drive how the Artemis astronauts interact and live on the surface for years to come. The RAC samples are a good collaboration between NASA and the public. Some of the samples are from NASA centers and some of the samples are from private industry. One day we're going to live and work on the moon, and we need to know, is there any water? Are there any volatiles, any kind of chemicals that we can use for manufacturing? Say we want to build a landing pad. How can we use the lunar soil to do that? I'm Dennis Harris. I'm the Lunar Payload Manager for Lunar PlanetVac. I'm based in Huntsville, Alabama at the Marshall Space Flight Center. Lunar PlanetVac is one of 10 NASA instruments flying on the next CLPS mission. It is designed to gather soil samples and either canister them up for a trip back to the Earth or to distribute them to any onboard instruments that might want to do in situ, and that is in-place measurements to look at the chemical composition of the soil. Space is limited on a rocket, and so is the mass. And so anything we can find on the surface that we can use to manufacture or build housing or launch pads is a benefit to the space program in the long term. The Lunar PlanetVac instrument will help us understand the environment on the moon and environments on other planets that we're going to travel to. The same company who's building Lunar PlanetVac is also have a very similar instrument flying to Phobos on a different mission. So we're going to look at these different environments that we have to live in long term and understand them better. Lunar PlanetVac is a collaboration with Honeybee Robotics, a company based out of Palo Alto, California. NASA Marshall's role is to facilitate the funding, the design, the build, the test, and delivery of the LPV to the spacecraft for delivery to the lunar surface. I'm excited to maybe have a chance to build a bunch of low-cost computers that will work in any situation in the solar system. And 2, it's very exciting to really have an empirical understanding of the radiation environment on the surface. Hi, I'm Dennis Harris, a Lunar Payload Manager for RadPC, which is the radiation-hardened PC that's going to fly to the moon. I'm based here in Huntsville, Alabama at Marshall Space Flight Center. RadPC is designed to be a low-cost option to radiation-hardened devices that are currently in operation. Basically, it's a self-correcting PC that will allow low-cost, almost commercial off-the-shelf parts to be used in future missions. The science from RadPC is going to be twofold. 1, it's going to be how to self-correct low-cost computing on space missions. And 2, it's going to give us a real feel for the radiation environment, not only on the surface of the moon, but through the Van Allen belts and through the entirety of the mission. So it fits in 2 ways. 1, it could allow us to have functional, low-cost computing power, not only on missions, but on the surface. The other way is that we're going to measure 2 different bands of radiation, a lower level and a higher level. That'll give us a much better feel for the radiation environment that the Artemis astronauts will be subjected to on their mission. I'm excited for the future of computing in space. I mean, having the option for a low-cost, radiation-tolerant computer is fabulous. And I'm also excited to understand the radiation environment. I mean, our astronaut safety comes first. And the Artemis astronauts are going to be on the moon for a long time. NGLR is a follow-on to the Apollo retroreflectors that have been on the moon since the 70s. It's more precise, it's a little bit larger, and it's designed to help us understand the movement of the moon. Hi, I'm Dennis Harris, the Lunar Payload Manager for the Next Generation Lunar Retroreflector, otherwise known as NGLR, and I'm at Marshall Space Flight Center in Huntsville, Alabama. NGLR is designed to return a laser pulse. It starts at the Earth, travels to the retroreflector, and then returns to the Earth. Large amount of science comes out of a simple instrument like a retroreflector. So the two things immediately is we can measure the precise distance, but also it gives us information about the liquid core of the moon and how it moves, which will help the astronauts who will spend time there to understand their environment. I'm excited because this is a follow-on to the Apollo retroreflectors, allowing us to have maybe even a 100-fold better idea of the precise distances to make our measurements more accurate and our predictions about general relativity and the interior of the moon more precise. NASA works in collaboration with the University of Maryland on the NGLR program. NASA Marshall's role is to facilitate the build, the test, the development, the design, and the delivery of the instrument to the lunar surface.